I'm going to try and help set up this exercise assignment 4-96, page 4-33. There's a Word document you can open up. You do not have to do a drawing of this. This is a harder part, but it's designed so that you won't have to do a drawing. In lieu of doing drawings, you shouldn't have to do tolerance and annotation and a drawing. You just do one or the other. But now there's so many people so confused they're doing both. So now you need to know both. So that's what I'm going to attempt to do with these exercises. Not only are we going to do just functional tolerance and annotation, or the 3D tolerancing, model-based definition is the name of this modules. We're going to do 5 of them, and you don't have to do the drawing. You just have to locate them in airplane coordinates, or some kind of coordinates that are given to you. XYZ coordinates, I should say. This particular part has been given XYZ coordinates, not particularly aircraft, marine, auto, just your XYZ coordinates, and everything's in metric. Okay? So in order to build this part, what I would establish is, I would establish 3 axes like you see in the tree here. The 3 axes I have is absolute axis, which is your 0, 0. And then axis system 2 is going to be where a line at the end of this point at this counterbore to this counterbore hole connects, and a line from the center of the circle perpendicular to that line to that center hole connects. That axis would help me establish an orientation to make this very simple to work with. Leaving it at these coordinates, you're going to see when you plop those points is it's all some weird angle. It's all funky looking. So to take a look at a completed part, this is a part looks normal, right? Because what we did was we built a local axis system. Now what I would have done different in this exercise is I wouldn't have erased this axis I used. This person decided to use this as your datum C. Right here, the YZ is datum C. XY would be his datum A. XZ is his datum B. And YZ, the datum C. So what I would do is I would build these parts. Now what I'm going to do is make the absolute axis the current axis. So when I hit ISO view, do it fit all in. I'm going to hit the ISO view. This is the true ISO view of your absolute coordinates. Notice that the part is canted in some weird angle, and that's why we build a local axis system. So my challenge to you is, before I show you how to do it, see if you can figure out how to build that in its true orientation. What you're given is the other hole locations of what it's going to mate up to. Alright, that's your hint for now. See if you can do it without me. In the next video, I'll show you how to set it up.